Okay, next question. So now, when we look at this question straight away, I know that this is the product rule. And the reason I know is because we were multiplying basically, x part in the first bit and an x part in the second bit. So we're going to allow u to equal the x minus x. Now, I know the x is up in the power, but it's still the product rule because you still have an x times an x. So when I go to differentiate du dx, I get just 1. Now, when I go to differentiate dv dx, some of you made a mistake here because you were thinking e to the x just becomes e to the x. And you're absolutely right, but this isn't just x, this is minus x. So if you want, you can go to the side and you can let u equals to minus x. You can then, again, treat it as if you're doing it from the beginning, e to the u. And yes, dy du is e to the u, but then you have to multiply it by the derivative of u. So du dx is minus 1. So it's actually minus e to the power u. So it's minus e to the minus x. So long story short, it is the exact same, but there is a minus in the front because you get a minus 1 when you differentiate the power itself. So maybe if you're getting stuck with that, go back and practice some of those negative exponentials. Now, this is our product rule. So we're going to do our u times dv dx plus v times du dx, which is 1. So it ends up becoming minus x e to the minus x plus e to the minus x. So that's the first one. That's my dy dx. Now, I also need, of course, so that's my dy dx done. I also need d2y dx squared. So I need to differentiate again. So when I go to differentiate again, this first one again is product. So I have to redo essentially this using my product rule. Now, it's basically going to be the same as what I've just done earlier, only this time I have a negative. So when I go to do my product rule on this, I just have to be careful to account for that. So sure, I'll just do it again from the beginning just to show you. So it's u is the minus x and v is e to the minus x. Now, du dx, in the last question, it was 1, but now, of course, it's minus 1. dv dx, now, if you look back up here, I don't need to do it all again because I've already done it. So when I differentiated this earlier, this is what I got. So I'm just going to literally fill that in. So that's minus e to the minus x. So when I piece it back together, du dx minus e to the minus x. Now, I still have to differentiate the second part. But again, because we've done that already, I know automatically that's going to be minus e to the minus x. So that's my second derivative done. Now, when I piece all of this together, I'm supposed to get 0. So let's see if I do. So I'm supposed to write down my d2y dx squared, which is what I'm doing twice, whatever my dy dx was. So I'm going to put that here. And then I'm supposed to add y. Now, y, of course, is originally what it was at the beginning, x e to the minus x. Apparently, this is all supposed to be equal to 0. So we'll see now if it is. So multiplying out the line, I'll just go down here. Multiplying out the line, so I'm going to just rewrite the first part. I'll write that as minus 2e to the minus x, actually. Then I multiply out my brackets. That's minus 2x e to the minus x plus 2e to the minus x. And then it's plus x e to the minus x. So let's see. I have 2 of these. So I have, well, they cancel, of course, straight away. And then if I have 1 of these and 1 of these, I have 2 of them, but then I'm minusing away 2 of them. So indeed, it all becomes 0. It's supposed to be 0, and it is. So that's me done, and I have shown that.